Hello everyone. So welcome back again. So here we are again solving questions from calculus. The topic is this differentiability and continuity. Okay. So this is the fourth part. इसके पहले के जो वीडियो है, I hope you have already seen those videos and you have understood all the questions. So let's start then. And these questions appeared in JEE Mains 2021. Okay. So now the first question. Now this is one very common question which has appeared so many times in JEE Mains. In fact, this appeared in JEE Advanced first. JEE में बहुत पहले एक question आया था इस type का, and then उसके variations have been asked in JEE Mains many times. So the question here is, let f is a function defined on R satisfying this condition. For every value of x, y belongs to R, f of 0 is equal to 1, then what is the condition? You have to check the conditions on fx. Now see, it is given that fx minus f of y, this is modulus, is less than or equal to, you can say this is modulus x minus y whole square. You can say this, right? Now this is true for any value of x and y. Now I can say this is fx minus f of y divided by x minus y modulus is less than equal to modulus of x minus y, just divided by x minus y modulus on both sides. Now see, if you just remember this, if you have limit h approaches 0, f of x plus h minus fx upon h, what is this? This is equal to f dash x, considering the function is differentiable. Or if you remember, limit x approaches a, fx minus f of a divided by x minus a. What is this? This is f dash a. This is the definition of derivative. This is the first principal definition of differentiation. Now here you can see here, if you just observe this, if I say this is this quantity, if this is true for any value of x, if I say x and y are very close to each other, that is, if I say limit x approaches y, this is fx minus f of y divided by x minus y modulus, this is less than equal to limit x approaches y, x minus y modulus, correct? Now what is this? I can say this is basically, you can say this is f dash y modulus, this is less than equal to, this is, you can see f dash y, you can compare this, this is less than equal to 0, correct? Now if I say modulus of f dash y is less than equal to 0, what does this imply? F dash y has to be equal to 0. Why f dash y has to be equal to 0? Because modulus cannot be negative, so the only possibility is f dash equal to 0. Now if I say f dash y is equal to 0, that means f of y has to be a constant function. That means f of y is a constant. Now what is f of this constant? It is given in the question that f of 0 is equal to 1. Now if f of 0 is equal to 1, that means c is also equal to 1 because it's a constant function here. So can we say this function is basically f of y is equal to 1, or you can say this function is f of x is equal to 1. This is just a variable, so you can say this is f of x is equal to 1. That means this function is always equal to 1. This is a constant function which is equal to 1, correct? So this is, you can say f can take any value, no. Fx is less than 0, no. This is f of x is equal to 0, no. F of x is always positive for every value of x. Okay, so this is the answer for this question. Very easy question. Now see, what can be the variation which have been asked? Let's say यहाँ पे we can put 3 by 2 power. वो एक बार already question आ चुका है. They can put power. Let's say this is x minus y raised to 4. It can be anything, but the concept remains same. Concept remains same, that how can you raise to f dash definition, first principle definition, and then accordingly we can solve this question. So I hope this is an easy question. You could easily solve this question in the exam, right? Now the next question is, let fx is equal to this is not differentiable at how many points? So correct. We have to check at how many points this function is not differentiable. So first let's observe this function here. So what is fx here? Fx is equal to x plus 2 into x minus, sorry, This is x plus 3 into x minus 1, right? Just factorizing this, and this is, you can say, e raised to, this is a perfect square, you can clearly see this is 3x minus 2 का full square. Modulus रखोगे नहीं रखोगे कोई फर्क नहीं पड़ता, because modulus of x square is same as x square, correct? So this is the expression we have, correct? Now observe this, you can clearly see this function, you can see this is non-differentiable at x equal to 1 and minus 3. You can see if you have y is equal to x plus 3, x minus 1. Let's say this is the graph, y is equal to x plus 3, x minus 1. It will be something like this, 1 and minus 3 are the roots. This will be a parabola, mouth opening upward. और जैसे आप इस पर मॉडुलस लगाओगे, so the graph will be something like this. It will shift. This is the graph of modulus of x plus 3, x minus 1. So these are the sharp corners, that is minus 3 and 1 are the non-differentiable points for this function. You can see this function is always differentiable. This function is always differentiable because 3x minus 2 square, इसको कोई problem नहीं है, e power कोई problem नहीं. This is always a differentiable function. Now see, if you have a function which is product of a non-differentiable into differentiable, what is differentiable function into a non-differentiable function? It can be a differentiable function or it may be a non-differentiable function. But if you just remember this, this is one very important point which you should note here, that if you have any function fx into gx, let's say consider this fx into gx. I am giving you the concept here, which is very useful for solving many product function questions. And if I say, let's say this function is a continuous and differentiable function at some point x equal to a. Let's say this is some function continuous and differentiable, and let's say this is a continuous and non-differentiable function. This is continuous and non-differentiable function. Now always remember this, if f of a is equal to 0, that means if the function which is continuous and differentiable is equal to 0 at this point x equal to a, this function fx into gx is a differentiable function. Very important point, because इससे you can solve so many questions जहाँ पे we have the product of function which is differentiable and non-differentiable function. And if I say f of a is not equal to 0, then fx into gx is definitely a non-differentiable function. This is the point which you understand, which you remember. Okay, किसी और वीडियो में I will give the proof of this, but you just remember for now that if you have fx into gx, one function is continuous and differentiable. That means both the functions should be continuous. One is differentiable, other is non-differentiable. Then add x equal to a. If this function which is continuous and differentiable, uska value is 0, then fx into gx, this product function will become differentiable. Otherwise, if at x equal to a this is non-zero, then fx into gx will be a non-differentiable function. तो बस आप ये देखो, what are the doubtful points for this function? किस point पे आपको check करने की जरूरत है? This function is non-differentiable at 1 and minus 3. This function is always a differentiable function. Now you can clearly see here, this function, this is continuous function. This function is also continuous function. And now see this value, this function which is a continuous and differentiable function, this is not equal to 0 at these points, which are non-differentiable points. एक बार फिर सुनिए, this is a non-differentiable continuous function. This is always continuous and differentiable. Now at these points, which are our doubtful points, जहाँ पे आपको check करना पड़ेगा, you can see at x equal to 1 and x equal to minus 3, because these are the critical points for this. At x equal to 1, you can see this function is non-zero. Similarly, at x equal to minus 3, this is also non-zero. That means at x equal to 1 and minus 3, this product function is non-differentiable. So you can say this is complete function is non-differentiable at x equal to 1 and minus 3. So that is the answer for this question. There are 2 points of non-differentiability. That is option 3. So this is an oral question. You can see just अगर आपको ये concept पता है तो. Otherwise, so you have to define this, you have to differentiate this, and then you will check this. Okay. So this is one very important point which you understand. Okay. Now let's move to the next question. Now this is, let f is defined from 0 to infinity to 0 to 3 be a function defined by this definition, and f is different, then you have to check f is differentiability in 0 to infinity and continuous 0 to infinity. Basically you have to check the continuity and differentiability of this function fx here. Now देखो, in this question this function fx is defined. This part you can easily check. The only problem comes for this. This is maximum of sin t if t is between 0 and x. How will you interpret this and x is varying from 0 to pi? To understand this, if I draw the graph of sin t, this is the graph of, let's say, sin x, correct? This is the graph of sin t. This is 0, this is pi, correct? And this is pi by 2. So what is this saying is sin t, this will be maximum value of this if t is varying from 0 to x and x is between 0 and pi. Now if you just observe here, if I say x is any value, for example, x is any value in between 0 and pi by 2. Let's say if I say x is equal to pi by 4, just for example. If I say x is equal to pi by 4, then what is the value? This is 0 to pi by 4. What is the maximum value? So it will be maximum value will be at pi by 4 only. This will be the maximum value because t is from 0 to pi by 4. So obviously this will be the maximum value. If I take, let's say the next value, let's say this is pi by 3, correct? This pi by 3 will be somewhere here. X is equal to pi by 3. Now between 0 and pi by 3, you can see this is between 0 and pi by 3. What is the maximum value? Obviously it will be pi by 3, sin pi by 3, the value at pi by 3. फिर आप पहुंचे pi by 2 पे. So you can see between 0 and pi by 2, what is the maximum value? This will be the maximum value. So you can see here, I can write this is fx is equal to if x is between 0 and pi by 2, x is between 0 and pi by 2, the maximum value will be equal to sin x only. Again you can see if you take any value between 0 and pi by 2, जो उस value पे value होगा वही उसका maximum value होगा function का. Sin का जो value होगा वही इसका maximum value होगा. अब जैसे आपने pi by 2 cross किया, now let's say you have x here. Let's say this is the value x. Now if x is between, if t is between 0 and x, you can see if t is between 0 and x, let's say this is some value 3 pi by 4. So you can see here, if you have this value, what is the maximum value now? Maximum value, you can see maximum value will be equal to 1 because उसके आगे value क्या हो गया, decrease हो गया. So similarly you can say if I take this value, what is the maximum value from 0 to this value? This is again 1. So can I say this is x is less than pi by, x is less than pi, less than or equal to pi, and greater than pi by 2, this is equal to 1. Because in that case sin का maximum value will be equal to 1. Okay. Now ये तो first part define हो गया. Now this is 2 plus x, this is x is greater than pi. This is how you can define this. Okay, you can just check this graph. भाई if you take any value x between pi by 2 and pi, यहाँ पे आप कोई भी value लोगे, तो t is varying from 0 to that value, 0 to that value. तो उसमें maximum value क्या होगा? Maximum value will be equal to 1 only. और अगर आपके पास 0 से pi by 2 में है, यहाँ पे कोई pi by 2 से पहले कोई value है, consider this case. Let me consider this case. Let's say यहाँ पे कोई value आ गया pi by 4, तो उस पे value check करोगे तो वही इसका 0 से उस value के बीच में वही value इसका maximum value बनेगा. So that is the function. अब आपको क्या check करना है? इसका continuity and differentiability. तो इसके लिए now you can easily solve. इसको आप ग्राफ से भी चेक कर सकते हो, अदरवाइज आप कंटिन्यूटी डायरेक्टली भी चेक कर सकते हो. यू कैन सी एट x इक्वल टू, दिस इज द ग्राफ ऑफ दिस फंक्शन fx sin x, ये pi by 2. तो फ्रॉम 0 टू pi by 2, दिस इज sin x, देन उसके बाद दिस इज इक्वल टू 1, y इज इक्वल टू 1, ये pi, दिस इज 1, देन at x equal to pi, this is pi plus 2. ये pi पे it will be pi plus 2. So this is pi plus 2 and then this is the graph. ठीक है? X greater than pi के लिए this is the graph. You can see this is open, this is closed. Right? So you can first see this function is, you can At 0 pi by 2 minus p, this is 1, pi by 2 plus p, this is 1, pi by 2 minus p, this is 1, but pi by 2 plus p, this is pi plus 2. So this is continuous at x equal to, this is, sorry, discontinuous at x equal to pi. Correct? X equal to pi पर discontinuous है first thing. ठीक है? तो obviously non differentiable at x equal to pi. बराबर? अगर discontinuous तो obviously non differentiable होगा ही. Continuous है pi by 2 पे, but अगर आपको differentiability check करना है तो आप क्या करो? This is continuous. If I just differentiate this, this will become cos x. And what is the derivative here? This is 0. Derivative of 1 will become 0. This is for x less than pi by 2. Let me write it here. If I write this fx, what is the derivative of this? This is cos x. हमको सिर्फ pi by 2 पे चेक करना है, बाकी pi पे हम ऑलरेडी चेक कर चुके हैं. ठीक है? This is not differentiable. तो pi by 2 पे derivative for this side is cos x and this is 0. This is for x less than pi by 2 and this is for x greater than pi by 2. ठीक है? बाकी हम चेक नहीं करें because we already know बाकी सब पॉइंट पे डिफरेंशिएबल है. ठीक है? Now pi by 2 minus पे इसका वैल्यू 0 हो गया. Cos pi by 2 minus pi by 2 plus पे this is 0. That means f pi by 2 plus f dash pi by 2 minus both are equal. That means this function is differentiable at x equal to pi by 2. So this is discontinuous at pi, non-differentiable at pi. That is this continuous at pi by 2, differentiable at pi by 2. ठीक है? So the question, the answer is f is differentiable everywhere. No, this is not correct. This is non-differentiable at pi. F is continuous everywhere but non-differentiable at 2 points. This is also not correct. F is not continuous. Exactly, this is also not correct. F is continuous everywhere but non-differentiable at exactly 1 point. So what is, sorry, this is actually, this is not 2 plus x, this is, wait, just wait. This is 2 plus cos x, not x. You can see this is 2 plus cos x. So now let's solve this again. So what are the limits? First let's check the continuity. Pi by 2 minus p, this is sin pi by 2, which is 1. Pi by 2 plus p, this is 1. So limit pi by 2 p, pi by 2 minus pi by 2 plus equal, that means pi by 2 p continuous, right? Then pi p, this is RHL is equal to cos pi by pi put करोगे, this is minus 1. This is 2 minus 1 मतलब 1. And this is pi minus p, this is also 1. So this fx is always continuous. Fx is always continuous function at every point. Continuous at every point. Now if you differentiate this, you can see this is how we can directly check the differentiability by differentiation. If the function is continuous, you differentiate it. This is cos x, this is 0, this is minus sin x, derivative. This is for x less than pi by 2 greater than 0. This is for x less than pi greater than pi by 2, and this is for x greater than pi. अभी we will put equality, we will check कि pi by 2 पे और pi पे ये differentiable है या नहीं. कैसे check करेंगे? Pi by 2 minus पे what is this limit? This is equal to 0. और pi by 2 plus पे what is this value? This is equal to 0. मतलब both are equal. LHD and RHD are equal at pi by 2. That means the function is differentiable. तो आप किसी भी एक पॉइंट पे put कर दो, तो that means function is differentiable at pi by 2. Now pi पे this is pi minus पे the limit is 0, this limit is 0, and pi plus पे this limit is also 0 because sin pi is 0. That means LHD and RHD at pi are 0. Both are equal. So again, that means this function is differentiable at pi. That means this function is continuous and differentiable at every point. Okay, so this function is continuous and differentiable at every point. That is option 1 will be the answer. Okay, so this is the correct answer. इसको आप 2 plus cos x करके solve कर लीजिए. Okay, so I hope this is clear. The most important part for this question is how you use this, how you defined this. Okay. Now let's move to the next question. The question says, again, you have to just check the continuity and differentiability of this function. The function is defined by this, the number of points where f is non-differentiable between -3 and +3. Okay, so yes, let f is defined. Now minimum of x and 2 minus x square, and this is box x if x is mod x is between 3 and 2. So first thing you can observe here, पहले तो इसको देख लो. What is this? This is modulus x is between 3 and 2. So this is x belongs to minus 3 to minus 2 union 2 to 3. This is the solution, right? Now we have to just see that this function is non-differentiable. तो ग्राफ बनाना, देखो ग्राफ कैसे ड्रॉ करेंगे. इसके लिए तो we can easily draw because we know between minus 3 and minus 2 this is minus 3, 2 and 3 this is equal to 2 because box function है. ठीक है. The point is the problem will be this way. ठीक है. So let's draw the graph of this. So here we have first x is between minus 2 and 2. This is minus 2, this is plus 2, and we have this 2 minus x square. So what is 2 minus x square? This is the parabola, mouth opening downward. X equal to 0 पे x is equal to 0 पे y is equal to, we have to draw the graph of y is equal to 2 minus x square. So this is x is equal to 0 पे, this is 2, right? Or this is between minus 2 and plus 2. Okay, so this is the graph at x equal to 2. This will be equal to minus 2 and minus 2, negative value. It will be something like this. ऐसा कुछ ग्राफ बनेगा. You can see between minus 2 and plus 2. Right? At x equal to 2 and minus 2, this function, this value will be equal to minus 2. Minus 2, you can check this. Okay? And this is y is equal to x. If y is equal to x. Okay? If x is between minus 2 and plus 2. So this is minimum of this. So y is equal to x is a straight line. So this is, I can draw the line y is equal to x. So y is equal to, this is minus 2. So this is y is equal to x will be something like this. You can say this is y is equal to x. Correct? This is y is equal to x. You can check this at x equal to minus 2, both are equal. Or आप ऐसा भी check कर सकते हैं, x is equal to 2 minus x square. So what is the solution? X square minus x minus 2 equal to 0, which is x minus 2 into x plus 1 equal to 0. So x is equal to 2 and minus 1 are the solutions. I think there is some y is equal to x. This is y is equal to x at x equal to 0. This is minus 2. One solution is minus 1. Minus 1 solution नहीं है. This is 2 minus x square. Oh, this is plus x. So this is x plus 2 into x minus 1. Correct. So this is x is equal to 1 or minus 2. So x is equal to minus 2, you can see, and x equal to 1. This is the solution. Right? Now, we have to write minimum of these two. Minimum of these two मतलब the graph which is below. ठीक है? तो minimum क्या होगा इन दोनों में? This is 0.1. This is 1. Okay? So now the graph which is below is this. You can see this is the graph which is below, and then after that this graph is below. Right? So this shaded part is the graph between minus 2 and plus 2. After that we have, you can see we have, if x is between minus 3 and minus 2, we have box x, and we know between minus 3 and minus 2 box x is equal to minus 3. So between minus 2 and minus 3, this is minus 3 somewhere. So this is box is equal to minus 3. You can see this is the graph minus 3. This is minus 3. Correct? And between 2 and 3, we know box of x is equal to 2. So this is between 2 and 3, this is box of x is equal to 2. So this is something like this, right? This is between 2 and 3, 2 is open and 3 is closed. So this is open and this is closed. So I hope this is clear. Between -3 and -2, -2 पे this is open, -3 पे box value is equal to -3. And then between 2 and 3, this is, I'll just draw this again. Between 2 and 3, box value is equal to 2. So this is 2 to 3 open. Okay, so this is the graph. Now the question is, you have to find between -3 close to +3, how many points are non-differentiable here. Okay, so now let's check how many points are non-differentiable. First thing, you can clearly see x is equal to -2. You can see x is equal to -2, right? Is a discontinuous point. You can see this is the graph between -3 and 2. I'll just shade this so it will be very clear that we are talking about this part. This is y is equal to x. Then we have this parabola, right? And uske baad we are talking about this, okay? This part of the graph. So now see, x is equal to -3. Sorry, x is equal to -2 is a discontinuous point. We have to talk about only -3 to -3 open intervals. So we are not interested in -3 and +3. Okay. So at -2, this is differentiable, not discontinuous. That is, this is not differentiable. At x equal to 1, you can see this is the sharp corner. You can see this is the graph here, and then we have this graph. So now this is the sharp corner. That means this x is equal to 1 is also a non-differentiable point. So there are only 2 points of non-differentiable, and again, sorry, and x equal to 2 also. And x equal to 2 also, x is equal to 2 is also a discontinuous point. So obviously it will be a non-differentiable point. So you can clearly see -2, 1, and then 2. These are the non-differentiable points for this non-differentiable points. So how many points? This is 3 non-differentiable points for this function. I hope this is clear. इसमें सिर्फ ग्राफ ड्रॉ करना आपको समझना है. Y is equal to x, you have this, and 2 minus x square, this is the graph of 2 minus x square. उसके बाद you can easily check this. Okay, so there are 3 points of non-differentiability for this function. Now let's move to the next question. The next question is, you have to find the points of non-differentiability for this function. So again, if you just observe here, we have a function which is fx is equal to modulus of 2x minus 1 minus 3 modulus of x plus 2, and this you can see this is x plus 2 into x minus 1 modulus. Correct? This is the function. इसको थोड़ा सा सिंप्लीफाई कर सकते हैं. This is modulus of 2x minus 1 minus 3 modulus of x plus 2 plus modulus x plus 2 modulus x minus 1. Correct? Or you can further simplify this. This is 2x minus 1 modulus plus, I can take this modulus x minus 2 outside, and in bracket you will have modulus x minus 1 minus 3. Okay, this is the function we have. You can check this. I have just taken this modulus x plus 2, sorry, x plus 2 common. Correct? X plus 2 modulus common, like you can see this is modulus x minus 1 minus 3. Right? Now see, we have to check the differentiability of this function. We have to check the differentiability of this function. Now, how can you check the differentiability? Again, you see, what are the points जहाँ पे हमको discuss करने की जरूरत है? What are the doubtful points for this function? So you can see here, at x equal to 1 by 2, this function is non-differentiable. At x equal to 1 by 2, this is non-differentiable. Correct? Modulus of 2x minus 1, you can clearly see this will be the graph of this at half. This will be the graph 2x minus 1 modulus. At x equal to minus 2, this function is non-differentiable. At x equal to minus 2, this is non-differentiable. And you can see this function, this bracket wala function, this is at x equal to 1, this function is non-differentiable. This function is non-differentiable at x equal to 1. So basically there are 3 points जहाँ पे हमको डिस्कस करने की जरूरत है. At x equal to 1/2, x is equal to -2, and x equal to 1. Now if you just observe here, if I take this point, x is equal to 1/2. Step by step देखते जाएंगे. At x equal to 1/2, this function is non-differentiable. This function is non-differentiable, but this function will be a differentiable function. Why differentiable function? Because x is equal to half पे इसको कोई problem है ही नहीं. X is equal to half पे इसको भी कोई problem नहीं. This is a differentiable into differentiable, which is a differentiable function. So at x equal to half, we have this function fx, which is combination of a non-differentiable plus a differentiable function. And we know what is non-differentiable plus non-differentiable. This is a non-differentiable function. मतलब x is equal to half is a non-differentiable point. Correct? Now, if you talk about x is equal to let's say -2. Okay? At x equal to -2, this function, this is a differentiable function. Because इसको कोई प्रॉब्लम ही नहीं -2 पे, इसको तो प्रॉब्लम था हाफ पे. हमने ऑलरेडी डिस्कस किया. x equal to -2 पे, this is a differentiable function. Now at x equal to -2, you can see this is non-differentiable into differentiable. Now how will you check this is at x equal to, see, just let me show you. At x equal to -2, ये हमने ऑलरेडी बोल दिया, this is differentiable. At x equal to -2, this is non-differentiable into differentiable, because x equal to -2 पे इसको कोई प्रॉब्लम नहीं है. ठीक है. Now in the previous question I had told you, if you have, this is the continuous function, this is the continuous function, differentiable, non-differentiable. If at x equal to -2, जो function differentiable है उसका value 0 हो गया, then this product function will be a differentiable function. Correct? So now see, at x equal to -2, at x equal to -2, इसका जो वैल्यू है, that is differentiable function का वैल्यू देखो, -2 पे ये क्या हो गया, -3, मतलब 3 - 3 मतलब 0. So this is 0 at -2. मतलब this function will be a differentiable function, that is differentiable plus differentiable will be a differentiable function. This is very important, but again I'm telling you this. Okay? Now if I take x is equal to 1, अब x is equal to 1 पे, again you can see this function has no problem. This is differentiable. Correct? Now at x equal to 1, this is differentiable. This is differentiable. Okay? At x equal to 1, this function is a differentiable function. This function is non-differentiable function, but at x equal to 1, इसका value 0 नहीं है. ठीक है? एक बार मैं फिर बता देता हूँ. You can just focus here. Modulus of x plus 2. You have modulus x minus 1 minus 3. ऐसा. ठीक है? Modulus x minus 1 minus 3. ऐसा. ठीक है? At x equal to 1, you can say this is continuous and differentiable. This is continuous and non-differentiable. But x is equal to 1 पे इसका value 0 नहीं है. जो function differentiable था उसका value 0 नहीं है. That means this product function will be a non-differentiable function. That is, this is non-differentiable. Differentiable plus non-differentiable. Correct? So what is differentiable plus non-differentiable? This is a non-differentiable function. So you can see what are the points of non-differentiability. X equal to 1/2 and x equal to 1. That means there are 2 points of non-differentiability of this function. So again, this is one very powerful result. How to check differentiability of a product function, which is one is non-differentiable, other is a differentiable function. So I hope this is clear. Okay. So that's it for this video. Next video में again I'll take some questions on differentiability, because अभी और कुछ questions हैं जो differentiability पे हैं. So that we will discuss in the next video. So that's it for now. Thank you.